in this video, we're going to be talking about equations of normal lines. Now, what a normal line is just a straight line that meets a curve at some point, and it is perpendicular to the curve at that point. So the angle that you get between the curve and the line here is 90 degrees. So let's talk about some of the steps that we're going to need to follow to find this equation. Now, the normal line is this blue one here. We first of all need to work out the gradient of the curve at this point. So we're working out the gradient at 2,8 of the curve, something like that here. To do that, we're going to need to differentiate the curve. And the equation of the curve is just down here. So we're going to differentiate that. And once we've done that, we are going to substitute in the x coordinate here, which in this case is 2. So we're going to work out the gradient of the curve at x is 2. Once we know the gradient of the curve here, we're going to use a perpendicular line formula to work out the steepness of this line. And finally, if we know the gradient of this normal line and we know a coordinate that it passes through, we can use the equation of a straight line y equals mx plus c and then get what we need. Now, I will be going through the process step by step, but if you are feeling confident, you might want to pause the video now and give it all a try. I'm just going to pop the answers in for each part right now, just so you know what should happen as you go through it. So if you differentiate the curve, we should get -4 from the first bit. We should get a gradient of 1/4 when we use the perpendicular line formula. And then finally, when we use the straight line formula, we'll get the equation y equals 1/4 x plus 7.5, which is 15/2. So that's what should happen. Let's go through the process step by step now. So the first thing that we're going to do is we're going to differentiate the curve. So the curve I have in this case is x squared, take away 8x plus 20. Now differentiating x squared gives me 2x, and remember the powers rule, which is I'm going to multiply by the current power, and then I'm going to subtract 1 from the power. So this is equivalent to 2x to the power of 1. When I differentiate -8x, I get -8. And when I differentiate plus 20, differentiating constants, they vanish. So we just have 2x minus 8 as dy dx. Now, we want to work out the gradient specifically at the point 2,8. So what we're going to do is we're going to plug in x is 2 into this formula here. So when x is 2, dy dx, instead of 2x, take away 8. Oops, that's not what I meant to write. 2x minus 8. I'm going to have 2 times 2 minus 8. And then working that one out, I should get a gradient. 2 times 2 is 4. Take away 8 is -4. Okay, so we've got a gradient of -4. That's the gradient of this dotted tangent here, and it's the gradient of the curve at this point. We need to find the gradient of this perpendicular line. And the perpendicular line formula is as follows. If you have two lines that are perpendicular, then their gradients, m1 and m2, the two gradients, should multiply to give -1. Now that formula can be rearranged slightly. And you can think about it as -1 over the regular gradient. So in this case, we've got a gradient of -4. That's what we got in the first part. That's here. So what we're going to do is we're going to take that and we're going to substitute it in for m2 here. And when I do that, I'm going to have -1 over -4. If I divide one negative by the other, the negative signs cancel out, and I just get 1/4 out. And that's my answer. So that 1/4 refers to the gradient of this blue normal line here. And finally, we know the gradient of this line is 1/4, We know a coordinate that it passes through, 2, 8. So I can use those pieces of information together with the straight line formula to work out what the intercept should be and then get the whole equation. So if I initially just write down y equals mx plus c, but I'll substitute in the gradient, which is a quarter, then what I'll do is I'll sub the coordinate in, which is 2, 8. So I'll replace x with 2, I'll replace y with 8, and I will get this. And then a quarter of 2 quarters is equal to a half. So this formula will look like this. 8 equals a half plus c. If I just take that half over to the left hand side, I'm going to have 8 minus a half is c. 8 take away 1 half is 7.5. So I'm going to write it as a decimal for now. 7.5. Alternatively, you can write it as a top heavy fraction. In this case, it would be 15 over 2. Now, putting that back into the equation of the line, y equals mx plus c, I know that m is a quarter. I know that c is either 17.5 or 15 over 2. I'm going to write it as a fraction just for consistency. And then that's the whole equation. I did it. Congratulations to myself. Let's highlight it. There we go. Beautiful. Very good. So just a reminder of the process again. We started by differentiating the curve to get the steepness of this section. Then we used the perpendicular line formula to work out the gradient of this line here. And then once we had the gradient and the point, we just plugged it into the straight line formula. Cool.